Welcome again to the continuation of the topic Latin square design. We said earlier before that this is one of the ANOVA we have. Now, in this Latin square design, we have a problem to solve on that. As you can see, this is a question on Latin square design. Now, question now is, how do we go about solving it? Before you solve it, you must know this Latin square design table. You must know this table, Latin square design table, which starts with source of variation, degree of freedom, sum of squares, mean of squares, and F ratio. Then, Latin square design has row, column, treatment, then error, then total. Okay? So, now, degree of freedom is M minus 1, M minus 1, M minus 1, M minus 1 bracket, M minus 2, then M squared minus 1. Then sum of squares, say sum of squares of the row, sum of squares of the column, sum of squares of the treatment, sum of squares of the error. Then mean of squares of the row, mean of squares of the column, mean of squares of the treatment, and mean of squares of the error. Then what you now do is that for the first F ratio, we have MS row divided by MS error. For the next one, MS column divided by MS error. For the next one, MS treatment divided by MS error. So that tells us that we have three conclusions in Latin square design. Then, how do we know our SS row? SS row equals to summation of yi squared all over m minus y squared all over m squared. Then we say SS column equal to summation of yj squared all over m minus y squared all over m squared. Then SS treatment equal to summation of yk squared all over m minus y squared all over m squared. Then SS total will now be summation of yijk squared minus y squared all over m squared. Then that means our SS error will now be SS total minus SS row minus SS column minus SS treatment. We said in the video before this that the treatment is gotten by randomization method, and you randomize this way: A, B, C, D, B, C, D, A, B, C, D, B, C, D. Then you say here is D, here is D, here is A, and here is A. So that is how to randomize 4 by 4 matrix or 4 by 4 Latin square design. We have written our formulas. Then what we now do is to go to the question in full and see how we can solve it. Now, to solve this question, call here yi and call here yj. Your yk is gotten from your treatment. Then, what do we mean by yi? Yi mean add up all these things you can see here. If you add 31 plus 33 plus 47 plus 54, what it will be giving you is 165. So once you add them, you will be getting 165. Then you add the second one, 36, 53 plus 42 plus 54, you will be getting 185. Then this plus this plus this plus this will be giving you 205. This plus this plus this plus this will be giving us 159 plus 72 plus 84. That will be giving us 208. So we'll be having it as 208. 81 plus 79, 159. Please, 159 plus 72, 11, 15, 12, 20. Okay, we'll be giving us 315. Then, when you add up everything here, if you add them up, it will be giving you 870. That is the total. Then you come to this side, you say 31 plus 36 plus 51 plus 81. If you add them up, it will be giving you 199. Then 33 plus 53 plus 43 plus 78. If you add them up, it will be giving you 207. Then if you add 47, 42, 62, 72, with add it up, it will be giving you 223. Then 54 plus 54 plus 49 plus 84. That will be giving us 241. So we have gotten a total for J and total for I. This is what we call our total Y. That is 870. If you add up everything here, 870. You add up everything here, 870. That is why it is at the middle. Now, in this question, they say 4 different drugs A, B, C, D have been experimented by using Latin square designs to see their effect on the weights of 4 pigs in 4 successive weeks. Results are shown in the table below. Analyze data and draw conclusion at alpha equal to B. So this is our level of significance. So for us to solve question on this, we must have our 4 figure table, because we have to read out a particular answer, that is F table, from our 4 figure table. So you get it, or you look for your F table using percentage point of F distribution. It is now 4 figure table, we all know. So look at for P, look at the information given to us. HO means non-hypothesis, HY means alternative hypothesis. HO no, HY alternative, HO no, HY alternative. So what we now do is we say from here MS row equals to SS row divided by M minus 1, MS column equal to SS column divided by M minus 1. That is this divided by this. Then MS treatment equal to SS treatment divided by M minus 1. Then MS error equal to SS error divided by M minus 1 bracket M minus 2. So we have derived formulas we need for this question. Then what we now do is we now proceed to computing our data so that we know what we are doing. Then we now say For SS row, this will be your row, the one of peak. SS row is talking about SS peak. SS for peak. So the formula is already here. What is our yi squared? What is our yi squared? Yi squared simply means all this. So we now say 165 squared all over 4, because it say all over m, plus the next one 185 squared all over 4, plus next one 205 squared all over 4, plus the next one 315 squared all over 4. You bracket. Say minus, they say y square over m square. Y square is what? 870. That is total. 870 squared all over. M square means our m is 4. Our m is 4. Why? 1, 2, 3, 4. So m square means 4 squared. 4 times 4, 16. If you compute this with your calculator, this square divided by 4 plus this square divided by 4 plus this square divided by 4, if you compute it very well with your calculator, you will be having here to be 50,675 minus, if you compute the next one, it will be giving you 306.25. So 47,306.25. Okay, when you subtract the two, it will be giving you, if you subtract it, it will be giving you 336.75. Just use your calculator and press it. Okay, we now go to SS column. SS column means SS week. SS for the one of week, and that is equals to, we go to the one of week. The one of week is this. So we start squaring 1, we start squaring 199 squared over 4 plus the next one 207 squared over 4 plus the next one 223 squared over 4 plus the next one 241 squared over 4 minus 870 squared over 16. Okay, so once you compute this, see where we got our values from. Once you compute it with our calculator, you'll be having it to be, this will be giving you 47,000 to be giving 47,565. Then minus 47,000, this one will be giving you 47,306.25. Then when you subtract the two, you will be having 258.75. Okay, we now go to our SS treatment. SS treatment. SS total, please. We go to our SS total. SS total says that the formula is this minus this. So what summation yijk square minus y square over m square mean is that you square each of these one after the other. So what we will do is that we say, okay, 31 squared plus 33 squared plus 47 squared plus 54 squared plus 36 squared plus 53 squared plus 42 squared plus 54 squared plus 51 squared plus 43 squared plus 62 squared plus 49 squared plus 81 squared plus 78 squared plus 72 squared plus 84 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have squared all of this. 31 square. So you square this, square this, square this, square this, and stop at the last one, 84. Then you now say minus, what is the total? 870 squared. 870 squared all over m squared is what? 16. Once you compute this, it will be giving you that your SS total equals to 51,540 minus 51,540 minus this will give you 47,306.25. Okay? So what you do is that when you subtract it, it will be giving you 4,233.75. So once you subtract the two, it will be giving us 4,233.75. That is our SS total. Then that tells us that our SS error, how do we get our SS treatment? Because we need to get our SS treatment. For you to get your SS treatment, which we also call the drug, you have to randomize. Randomizing say A, B, C, D, A, B, C, D, A, B, C, D. So we follow that pattern. We call here A, we call here B, we call here C, we call here D, then A, B, C, D. A, B, C, D. Then A, B, C, D. Then we now say here is D, and here is D. Here is A, and here is A. We have succeeded in randomizing it. So what matters now is that you write your A here, write your B here, write your C, and write your D. The first A we have is 31. Next one that we have is 42. Next A we have is 43. And next A we have is 84. Okay? Then what of B? The first B we have is 33. Next B we have is 36. Next B we have is 49. And next B we have is 72. What of C? The C we have are first one 47. 47. The next one, the first C we have is 47. The next one we have is 54. The next one we have is 51. The next one we have is 78. Then what of D? First one 54. Next one is 53. Next one is 62. Next one is 81. Then get their total. 31 plus this 73. 73 plus 43. 73 plus 43 will be giving you 116. 116 plus 84 will be giving you 200. The next one, if you add the next one, you will be having 33 plus this 69. 69 plus 49, 118. 118 will be giving you 118 plus 72 will be giving you 190. Then if you add the next one, you will be getting 230. And if you add the next one, you'll be getting 250. This is 107, 169. That is 250. So we have gotten our, so we call this YK. This is our YK. So that is all we use to get SS treatment. We can now clean the formula we have here so that we can write SS treatment. We say SS treatment is equals to, look at the formula, summation of YK squared minus y squared all over m squared. So SS treatment will be, we say 200 squared all over 4 plus 190 squared all over 4 plus 230 squared all over 4 plus 250 squared all over 4. Once you sort it out, minus y squared is 870 squared all over 16. That is 4 times 4. So, if you compute this, if you compute it, you'll be having that. If you compute it with your calculator, you'll be getting that all this will be giving you 47,875. 47,875 minus 47,306.25. So once we subtract this, that will be giving us 568.75. So that is our SS treatment. So we have gotten our SS row, SS column, SS total, and SS treatment. When I say finally, we say that our SS error will now be equals to, when I say SS total is 4233.75 minus SS row is 3368.75 minus SS column is 258.75 minus SS treatment is 556.75. Okay, so once you subtract it, you'll be having your SS error to be 37.50. Okay, so You have been able to get your SS error, SS treatment, SS row, SS column. Remember, SS row is one of peak, SS column is one of weak, SS treatment is one of drop, and the SS error is this. So what you now do is that you come to your table and you start substituting your values. M minus 1, our M is 4. M minus 1 will be giving you 4 minus 1, 3. 4 minus 1, 3. 4 minus 1, 3. 4 minus 1, 3. 4 minus 2, 2. This times the 6. Then, if you add it up, 6, 9, 15. You see is your SS total. SS row, what did we get? From our SS row, we got 8.75. SS column, we have 258.75. SS treatment, we have 568.75. SS error will be giving us 37.50. What is our MS row? MS row will be giving us this divide this. That will be giving us 1122.92. Okay? Then MS column, this divided by this, that will be giving us 86.25. The MS treatment will be giving us this divided by this, that will giving us 189.58. What is our MS error? That will be giving us 6.25. Then F ratio means this divided by this, MS row divided by MS error. What is MS row? This MS error, this when you divide them, we'll be having 179.66. Then when you divide MS column by MS error, you'll be having 13.80. Then when you divide this, MS treatment over MS error, it will be giving you 30.33. Okay? This is called F calculated. So this is the first, the second, and the third. That means we will have 3 conclusions. And that 3 conclusions is based on the null hypothesis, alternative hypothesis, null hypothesis, alternative hypothesis, null hypothesis, alternative hypothesis. Okay? Then what you now do is you now say, let me conclude. I will now say my conclusion is test the first one. You have 179.66. Are you greater than F table? How do you get your F table? You get your F table at alpha 0.05, because they say test at alpha 0.05 bracket. For the first one, the degree of freedom is 3, and the degree of freedom of error is what? Set. So this is numerator, while this is denominator. Now, you have to check out this from your 4-figure table. You check your 4-figure table, other percentage point of F distribution. You say 3 against 6 3 against 6 under 0.05. That will be giving me 4.76. I will say everything here is 4.76. I'll ask myself 179.66. Are you greater than 4.76? Yes. Now, if it is greater than 4.76, they say reject null hypothesis. Because what you calculated is greater than what you got from your table, reject null hypothesis. Hence, accept alternative hypothesis and say there is significant difference among the peaks. Because the first one talk about peaks. So there is significant difference among the peaks. That is our conclusion for question 1. For decision 2, we now compare 13.80. Are you greater than F 0.05? Bracket. What is the column of it? What is the degree 3? And what is the error 6? This is denominator and this is numerator and the other one denominator. You still go to your table and locate it under percentage point of F distribution. You locate it, it will be giving you 4.76 as well. You say 13.80, are you greater than 4.76? You say yes, it is greater than 4.76. Once this is greater than 4.76, reject null hypothesis. Reject null hypothesis. You know that this is for the one of weeks, while this is for the one of peaks. So here we rejected null hypothesis for the one of peaks and accepted alternative hypothesis. But in the second one, we also reject null hypothesis, that is for the one of weeks, and accepted the alternative hypothesis. Here, in that one of weeks, which we have here, we say there is significant difference among the weeks. Yes, we have rejected the one of null hypothesis that said there is no significant difference among the weeks. So there is significant difference among the weeks. Then we go to the last one. We test whether 30.33 is greater than F table. And our F table is check from your fourth figure table 0.05, which is your level of significance. Then your treatment is 3, and the other one is what? Error is 6. So once you check this, it will also give you 4.76. So 30.33. Are you also greater than 4.76? Yes. So you also say reject null hypothesis. So as you are rejecting the null hypothesis, this one is for the one of drugs. The third one is one of drugs. So there is no significant difference among the drugs. You are rejecting null hypothesis, meaning I am rejecting the first statement, taking the second statement, which is alternative. I am not taking alternative hypothesis that say there is significant difference among the drugs. So I have 3 conclusions in this. 1, for the one of peaks, there is significant difference among the peaks. For the one of weeks, there is significant difference among the weeks. And the one of drugs, there is also significant difference among the drugs. See you in the next video. Please don't forget to click like button as you enjoy the topic and click subscribe. It will not take your megabyte or your money. Then keep in touch with our videos. See you in the next video.